Lesson 6, Analog Input 2. In this lesson, we will be going through photoresistor, and then we will try and make a night light. Then we will go through, so that's the last for the analog input. Then we'll go on to ultrasonic distance sensor. Then we will try and make another music instrument. So photoresistor is a light dependent resistor. That's another name for it. So it's a variable resistor, just like a potentiometer, but it is sensitive to light. So when it's dark, as you can see from this chart graph, you can see that when it's dark, the resistance is high. When it's bright, the resistance is low. And why do we want to use cadmium sulfide for these photoresistor? This is because just for this photoresistor, the reason is because its spectral response curve closely matches that of the human eye. So visually we can use this for our circuit. So we are going to continue. So the very basic setup, we will always do this for all the circuit. We always read, and then after we like it to be printed to the serial monitor to see the result. So we are going to do this. This is called a voltage divider setup. So if you would like to know more about this setup, you can click on the link to find out more. Okay, so we are going to go to here and create a new circuit. Okay, then we have 5 volt. Okay, then the next part is we're going to take out the photoresistor. So this is the photoresistor. Then another resistor. This should be 10k ohm. Then we have this 5 volt. So we need this to be the 5 volt to go through this resistor, and after it goes through the resistor, we will do the reading to here, A0 orange. Okay, so 5 volt goes through this resistor, and then you will do the reading. We need a 10k ohm here so that it protects the circuit from short circuit. So next, what do we do is we will go to code, and we are going to delete this away. We are going to print to serial monitor. Okay, and what do we print? We are going to print the input analog pin A0. Okay, so like this. So I'm going to start simulation. So when it's dark, is actually okay. So high resistance, so the reading is low. When it's bright, low resistance, the reading is high. So it's actually 974. So that is the reason why So like this setup for this part is done. We are going to start to do it on our this Arduino. So you can go to blocks plus text, copy out this, and maybe you delete away the delay, because it says here delay a little bit is to improve simulation performance, but we are not doing a simulation when we are working on the Arduino, so you can actually delete that line. Okay, So we are going to start to go up the circuit. We'll quickly do this. Okay, so that's my 10k ohm. This is my photo resistor. So let's just focus. Okay, so it looks like this, very long legs. So we are going to plug this in here. Okay, done. Then comes the wires. So I'm going to plug 5 volt direct to 5 volt, because actually I don't need to go to another. I don't need it for later my circuit. So actually I don't need to do that. But this one I need to. I will connect this to the ground. So I save one wire. Then I will use another wire for A0. Okay, so I think I need to do some adjustments to the resistor. Okay, make sure that you are putting into the right positions. So okay, corrected this just now. The resistor was at the wrong leg, a bit too far, one spot too far. Okay, A0. Okay, done. So this setup is done. We're going to plug this into the computer, and next open up the Arduino. From here I type in serial.begin 9600. Then here what we are going to do is we're going to say serial. So it's the same as what is written here. It's almost the same. Okay, so but I just like to type it out because it's this simple. Serial.println, so that you know how to do it. Serial.println. So what we're printing is analog read A0. Okay, so this is completed. We are going to start. Tools, serial monitor. Okay, error occurred. Let's check. Okay, port not set. Just make sure you set it. Okay, so now it's showing the reading as 797. So when it's covered, it will drop to 400. Okay, so you can see that you can actually see the numbers drop when it's covered. So now all the lights are on. I'm going to switch off the lights and take note of the reading. So now it's 797, about that, 7947 plus 790 plus. I'm going to switch off the lights now. Okay, so when the lights is off, it's about 500 plus, 520 around there, 520, 790 plus. So take note of the two numbers. So what I'd like to do is I just open text edit, a new text, and I just write down off. When lights are off is about 520. When on is about 790, around there. So we get a rough gauge of what numbers to play with later when we want to create our night light. Okay, so that portion of it is done. We're going to go on to the next part. Okay, so to do a night light, we need to tell it to at what reading do we switch on the lights or switch off the lights. So from here, what we do is we go to circuit, okay, and we can add in a LED. So we should keep it slightly further apart. I like to keep it slightly further apart because to show that the lights actually will affect the LDR, okay, which is a light dependent resistor or photoresistor, this one. Okay, so I like to put it further apart, but actually the photoresistor is taller because of the long legs of the photoresistor, so actually it doesn't really affect much. So but then I'll just still keep it apart, 330 ohm, and this I'm going to connect this to pin 7. Okay, I'll just give you another color. Okay, so that's my setup. Next, go to code. I'm going to say that if else statement. So if for this circuit, okay, if the center is about 940, so I'm going to say, just now I already see the numbers is about 940, 930, whatever. So what I'm going to do is, if it's lower than 940, so if the reading is lower than 940, I'll switch on the lights, okay, the LED. So if analog pin is lower than maybe 940, okay, you can play around with numbers. I'm going to just put 940 as the number, and if it is lower than 940, I will switch on pin 7, then duplicate, put here low. Okay, so we're going to start simulation. Okay, it lights up because it's dark. Then when it goes to the other side, when it's brighter, it switch off the LED. When it goes to the other side, it switch on the LED. So done. We are going to replicate that in the Arduino. So I'm going to unplug. Okay, make sure you unplug power, and okay, we are going to plug in our LED. Okay, so this will be like to be here. Resistor 330 ohm. Make sure you are using 330 ohm. Okay, then we are going to use this, plug this to 7. Okay, done. Pin 7. Okay, all good. Then we are going to plug this in. We're going to write the code. Okay, so now what we need to add in order for the LED to work is we need to say pin mode 7 output. Then we need to have our if else statement. So if else statement, you can also use the Tinkercad to help you to copy and paste it out. So you can actually go to here, code, and then from here you can actually copy this out. But I'm not going to do that. Instead, what I'm going to do is I'm going to write it out here. If, okay, so you can see that it helps you open and close. Usually people will write the else here, but I like to just to make it more readable. Else, or no, else don't need that. Okay, if else, so we have if else here, so there is a statement here, so you should have a statement here. Then you have do something, okay, do something, and then I'll have another if or else, you do another thing here. So this is the structure for the statement. So statement is analog read A0 and smaller than. So what number do we put in? So you know that when my lights are off, that means it's dark. Okay, dark is 520. When it's bright, okay, when the lights are on, is 790. So the number that you put in can be about I think maybe you can put 650. Okay, so I'm going to just try 650. Should work. And I'm going to say digital right 7 high, and then just copy this out, 7 low. Done. Okay, so once this is done, we can actually push this into circuit. So oops, yeah, this one not needed, so I'm going to delete. Okay, can. So I'm going to push this in now. Okay, so okay, in. So now the lights are on and the LED is off. We'll switch off the light to show that the LED will light up. Okay, so our night light works. When I switch off the light, the LED switches off. When I switch off the light, the LED switches on, and when I switch off it, the LED switch off. Switch on the light, LED switch off. Okay, so it works. The night light works. Okay, that's it for the night light part. Next, okay, we are going to talk about this ultrasonic distance sensor. So it works a bit like sonar. So sonar for animals, they use this is called echolocation. So they will emit a sound, and after that, when the returning sound wave, it picks up the returning sound wave, we can roughly estimate the distance and the position of the object. For in this case of the bat and the dolphin is their prey. For navigation, for the submarine, they also use sonar. Okay, so for this ultrasonic distance sensor, the same thing. It works the same way. It sends out a wave, sound wave. Okay, and then after that, it hits the object. It comes back reflected wave. So from the time for the wave to return, and you know the speed of sound, you'll be able to calculate the distance. Okay, so we are going to use the HCSR04. So the HCSR04 is inside here. So I'm going to just clear out those that are not needed. So I don't need these. Okay, I'm just going to delete most of the stuff. Okay, and I'm going to just search for the ultrasonic distance sensor. If you scroll down, you see these. Take it out. Then there is also but this is basic, so you can actually see that these 3 pin. I'm going to find another one for you to compare. So ultrasonic distance sensor. Oops. The next one is this. So you can actually see that there's a difference between the 2 ultrasonic distance sensor. This is using 3 pins, the same pin to emit and receive the signal, but this uses a dedicated pin to trigger an echo. So we are using this. This is what is inside your box. So you delete away this, and you should be using this. So go and search for ultrasonic distance sensor and use the one that is HCSR04. So here we are going to plug in all the wires correctly. So this is red and this is black. Okay, and we are going to have to connect these to, I'm going to like to connect these to 6, and then I connect these to 7. So this is green. Okay, so very simple. This is done already. You will be able to track distance using this. We are going to continue with the coding. So here what we need to do is I will just delete this. Okay, delete this, and the input instead will be changed to read ultrasonic distance sensor. Now this is not analog reading. Okay, this is not analog reading, this is still digital reading, but we are going to use 6 and 7. So because I plug into 6 and 7, I'm going to use the 6 and 7. Okay, so it is not, it is just a digital reading. So it is actually listening to, as you can see, one is output. Okay, the trigger pin is the output. Okay, so these two blocks actually save you a lot of time because it auto generates all this. So let me just maybe briefly go through this part. So trigger pin has output, and then after that it has a trigger input pin, input for echo pin. So basically it will take in, and then it will calculate the time taken for the sound to return, and then you will actually tell the distance in cm. You will actually convert it into cm. Okay, so so this actually saves us a lot of time. I'm not going to go through the whole part for here. So from here we can actually open up the, okay, I'm just going to hide the text. Okay, I'm going to just lower this, start simulation. So you can see the distance 113.4, 113 plus. So if I shift down, you will see that the distance is changed, 78 plus. Okay, it's around there. So this is how you can read distance. We are going to, if you want units, you can actually do it by saying this one without new line, and then you can maybe say that you can actually put in that you print to serial monitor. Okay, cm. Okay, so you have units for this, so you can start simulation, and now it has a cm. If okay, so that is how you can actually do it if you want to. Okay, so this part is done. We're going to quickly go and do it on the circuit. So let's go back to circuit. So I'm going to plug out whatever are not needed. Okay, so okay, so next we have to take out our ultrasonic distance sensor, the HCSR04. So it is here, and then in this here it actually mark out all the positions for the cables. Make sure you know where you plugging it to. So if you look at it like this, VCC 5V is on the left. If you turn it the other side, VCC is of course on the right, but there are people who actually will not plug it in the right places. So make sure you check before you do any of the plugging of the cables, and double check, then you connect to power, or else your board will stop working. Okay, so I'm going to plug this here. Yeah, I like to plug it this way because you don't want to plug it in front. Okay, if you plug it in front, then how are you going to, you plug it like this, it's hard for you to plug in your cables here. So please plug it the other way. So plug it here like this, then we will have our jumper wires. Okay, make sure you plug it correctly. So 5V is here, so we plug it 5V here, and then we have our other wires 6 and 7. So this is 7, I need another one for 6. Okay, 6 and 7, so 6, 7, so this is for 6. Trigger pin. Okay, sometimes it's a bit hard to push this in, so maybe you need to make some adjustments, or maybe use another pinhole for this. Okay, so 1 2 trigger echo, and then we have the ground here. Done. Okay, so make sure you check. So, okay, so this part is done already. I can just rotate here, okay, like this. So this is the setup. Yeah, I like to do it like this. Next, what we're gonna do is we're gonna write the code. No, we're not gonna write it. We are just gonna delete. We're gonna just copy from here. Okay, blocks plus text. Okay, the easy way is to just copy from here. Copy whole thing. Make sure you copy finish the whole thing and paste this in. Delete the delay 10 millisecond because you don't need, you are not simulating. Next, once all this is done already, you can actually push this into the board. I'm going to plug this in and I'm going to start simulation. No, not simulation, the pushing it into the board. Serial monitor. Okay. Okay, so it's reading the distance. I'm going to just put it here. So it is actually reading the distance. I'm going to just shift the okay here. Okay, so like this. So it is actually reading. I'm just going to adjust this to show you. So the O number will be the one that is working. So it's detecting something in front that is 147 centimeter away. So if I put my hand in front of this, okay, as you can see, it's detecting about 5.8 centimeter. And if I move nearer to it, it's detecting as 2.5, about 2.5 centimeter. If I move further away, 11.44 centimeter. It's about there. Okay, 11 centimeter. Move further away, 16 centimeter. Okay, so that's how you do up the ultrasonic distance sensor for reading the distance. Okay, so if you want to, you can actually combine the okay, so that's what we did. So you can actually do this theremin setup. That means we plug in the piezo. Okay, so we put in a piezo speaker, and then we can actually make a music instrument. Okay, so do the theremin. So that is another setup that you can actually try and do. Maybe we'll try and do this. The code is this, so we need to add on more things. The difference is that we instead of having to read every single time, we can actually set a variable. I'm going to do this now. Let me just settle this screen first. So okay, good. So that's how I want it. Okay, great. So I'm going to try and do this. Okay, so we are going to have to plug in the piezo. Okay, I'm going to plug in the piezo here, and then negative to the ground. Okay, black, and then after that we have 1 to pin 8. So we're going to plug this to pin 8 now. So this is 8. It's yellow maybe. Okay, so next code. What we do is maybe I don't want the units now. I don't want to have maybe I don't want to print to serial monitor first. Okay, maybe we print to serial monitor so that we can see some information, but maybe we will modify a bit. Oh yeah, so variable. So variable, create a new variable. We are going to call it distance, short for distance, dist. So every single time we are going to read. So every single loop it will read the distance, and then after that we will print this to a serial monitor so we know the distance. Then after we have read the distance with new line, so we're going to go on the new line. Then we will use this method to actually adjust the distance, and we are going to map it to range. So I think I will do like this. Okay, so if else statement. Okay, and then okay, we will do math. and or. So if it's too far away, we are not going to do anything to this. We are not going to play any sound lah. So then after that we have the smaller than equal to, then we'll put in the distance. So if distance is 40, okay, smaller than 40 and larger than 140, okay, larger than 140. So I'm going to just duplicate this, plug this in here, 140. If it's 140, larger than 140, what we're going to do is we're going to say that turn off, don't play anything. Okay, so if too far away, I'm going to turn off this. So turn off speaker on pin 8. For this example, maybe I already know how near I want. Maybe I'm not going to put so far. I'm going to put 10 cm. And if it's too near, don't play any sound. If it's 140, maybe I'll try this figure. Yeah, maybe I'll try this figure. No, maybe I'll just put 80. Okay, so this is for real life. I'm going to do that, and I'm going to say play speaker on pin 8. So this one later you can go and adjust this. We are going to say play speaker on pin 8 map. Play speaker on pin 8. Tone. Okay, so we need to map the tone. So we are going to map this to range. Map to range. Map distance, okay, to the sound range that we want. So 50 to 75. The tone cannot exceed 50 to 75. So the max and minimum will be mapped to 50, 75 for I'm not going to play for 1 second. 0.1 second. Make sure you also put in a wait time of 0.1 second. Okay, actually this is important because you only play for 0.1 second. Okay, so yeah, 0.1 second will do. Okay, to keep it consistent, 100 millisecond. So like this, it should be okay. Later we may need to do some testing, and we need to make some changes to the mapping, because the map of the distance 0 to 1023 is no longer 0 to 1023. We need to actually modify this. Okay, so we are going to copy this whole thing out. Okay, so we go and copy this. I'm not going to test this on in here. So I'm going to just copy this whole thing, copy, and I'm going to paste this into Arduino. So I'm going to paste this into the Arduino. Maybe before I paste this into Arduino, I'm going to set the reading. So tools, serial monitor, okay, reading. So how far away. So for this, now the reading is, we'll copy paste first. Okay, so distance is 10 and 80. So 10, so I'm going to try and read. So 10, okay, so this is 10. So I know this is the minimum distance I need to have, play the sound. And then 80, I'm going to just drag further 80. Okay, 80. So I know this is a comfortable range for me to do this activity. Okay, 10 to 80, around there. So I'm going to later when I play the sound, if I know the range that my hand can go, play the theremin. Okay, so theremin is a music instrument whereby you don't touch it, you just use your hand to based on the distance, we are going to make a pseudo theremin. So based on the distance, it will play the sound. So I'm going to plug out this, and I'm going to plug in the circuit for the piezo speaker. Okay, take note for the piezo speaker, right? There is actually a plus minus on plus on the thing. Can you see the plus? Plus. Okay, there's a plus, and then there's a XH. Maybe there's an XH there, but a plus with a circle, that is where you want. That is where you want to plug in the pin 8. Okay, so I'm going to plug this in. Okay. Okay, make sure you know where you plug in the thing. So I'm going to adjust. So pin 23 is where I put in the plus. I'm going to plug it the 23 to pin 8. Then I'm going to plug in another jumper wire. This time round it's going to be 26. Okay, maybe I should just, maybe the legs I should just shift it a little. Okay, maybe it's too wide already. So 20. Okay, white is never mind. 23 and 26. Okay, 23 and 26. 26. Plug it to the ground. Done. Okay, need to try and adjust and get into place. Okay, done. Sometimes it's a bit hard to get it in because of alignment, but slowly adjust and you'll be able to get it in. Next, I'm going to plug this in, and I'm going to flash this to the board. Okay, hold on. Serial port, USB modem 1101. Okay, try again. Okay, done uploading. We'll look at the serial monitor. Okay, so it is reading 57139. Let's see. Okay, we need to make changes to this. So because we haven't made changes to this, so 1080. So you see here is 10, here is 80. We should actually map the distance to 10 and 80. Okay, or else it will not work. Let's try this again. Okay, hold on. Okay, it's not working. Hold on, I need to check the circuit. Okay, 23, 6, 8. Tone 8 map distance power to 50 to 75. Wait for 100 millisecond. 35, 127 minus 12, 100 millisecond. Okay, let's try this on simulation. Okay, that works, but there is some issues here. Hold on. Yeah, sometimes it could be a problem with the piezo. Let me just check. Oh, I know why. Because I haven't plugged into the ground. Okay, finally I know why, what went wrong. Okay, so we're going to feed this again into the board. Okay, I'm trying to restrict this so that it will fit closer to the board. Then I will adjust the wires. Okay, then this 25. Now I'm going to plug it to 25. I'm going to need to plug this to the ground. So there are a few places where if I plug it to the ground, I'm going to plug it here. Okay, instead. And okay, it works. So it works now. Hold on, I need to show you using my hand. Okay, so the theremin works, and that's it for this lesson. Thank you.